Hi guys, welcome to my YouTube channel. Today I want to discuss more examples in balancing chemical equations as we go through more and more examples, making sure that you guys can master how to balance literally any chemical equation, except for the redox that we have to have acquire more skills to be able to balance them. But any sort of normal, not redox reaction, you should be able to balance without difficulty. So let's go to this first example, chromium plus O2, giving you chromium 2O3. And I'm gonna start with putting the coefficients for this one first. If I put 1 for this, that would be 2 chromium, so that would be 2 here, that's the metal, so I go first with that, and 3 oxygen, so that would be 3 halves. I could also say I can multiply everything by 2 to make it 4, 3, 2 here. Okay, also let's do this one, NH3. Some students find this difficult to do, I don't know why. I'm just going to do it right here so you could see how easy these reactions are. So NH3 and H2O, I choose this one because this one contains nitrogen, and oxygen and hydrogens are the last things I want to take care of. Okay, so one here and one here because of the nitrogen. As soon as I do that, I realize that I have 3 hydrogens, so I do 3 halves here. I want to actually put my oxygens here, and I can't continue counting with this. Okay, at 3 half of oxygen, so I multiply everything by 2, and that gives me 2, 3, 2, and then I could count my oxygens and 3 halves here to make 3 oxygens for that one. Now I could also multiply everything one more time with 2 to get rid of the second coefficient, so this becomes a 4, this also becomes a 4, and this becomes 6. Or you could stay with whatever you had, so that's the balancing of this equation as well. Let's go with another example, CH6 N2 plus O2 giving you N2, CO2, and finally H2O. Okay, so I certainly start with this, put a 1 here, 1 carbon, so 1 carbon, 2 nitrogen, so 2 nitrogen, 6 hydrogens, so 6 hydrogens, and I have 3 oxygen here and 2 oxygen here, so 5 oxygen, so I do 5 over 2. I could then multiply everything by 2 to actually get rid of these 2 here. Okay, and that becomes 2, 5, 2, 2, 6. That's this. Let's move on to more examples. Let's go on to this reaction of phosphorus P4 plus S8 giving you P4S3. I certainly go with this one. It has the variety and it doesn't has the maximum number, but it has the variety. Okay, so let's just take care of the variety and the maximum at the same time as I look at these two. I want something that gives a 3 and an 8 a common number. Okay, if I do put 1 here, then this thing should be a combination of 4. Okay, or if I do something that is 1 here, actually I want something to make a combination or a factor of 8. So the best thing to do if you start with this, instead of 1 just put this number, and if you start with this, just instead of 1 put this number. Okay, for the sulfur. So I either start with this one and 8, or I start with this one and put a 3. If I put a 3, that's 8 times 3, so this should be 3 times 8 to make you 24 sulfurs. 8 times 4, that is 20, that is 32 phosphorus, and I do also 8 here to get 32 phosphorus exactly. So that's how I do this. Let's go on, move on to yet another example. C3H6 plus O2, it's a burning example. Okay, giving you, but it's not complete burning because it doesn't give you CO2 but rather carbon monoxide, which is a carbon bonded to just only one oxygen, and that means it's going to be a little bit different than a normal burning. But the strategy hopefully is not going to change. So we choose this one. I put a 1 times 3 carbons, so 3 here, also 6 hydrogens, so 3 here to make 6 hydrogens. I have 3 oxygens here, 3 oxygens here, it's 6 oxygens, and I put 3 over here to make also, that also makes, oh my bad, I apologize for the inconvenience. That's going to be the balanced reaction. Let's move on to yet another example down below. Calcium H2, this is bihydrogen or dihydrogen phosphate, okay, and the anion is just H2PO4 1 minus. That's bihydrogen phosphate, 2 of it, and then NaHCO3 bicarbonate, sodium bicarbonate, giving you CO2, H2O, calcium. Oh, let's just get some space on the top so I could continue doing this whole thing on the top. Let's just say it gives you calcium hydrogen phosphate and some oops, my bad. Sorry if this space is not enough to do a straight line, so I have to do this a little bit more inconvenience, and some sodium HPO4 as well. Okay, so the first things are the metals. We first start with this one because it has a 2 for phosphorus. None of these have, it's just have 1 phosphorus and a calcium. Okay, so it's most variety with most coefficients. We don't care about oxygens and hydrogens because those are the 2 that we don't care. So if I put 1 here, it means now 2 phosphorus. I can't judge how to distribute those 2, but there is 1 calcium. So if it's, I put 1 calcium here, then it means also 1 phosphorus because it's 2 phosphorus here, 2p, 1 times 2, that makes 2, and 1 times 1, 1 times 1, 2 phosphorus. So that's how I put 1 here. If I put 1, it's now 2 sodiums, and this should be also 2. And if I put 2 sodiums, this is 2 carbons here, so that should be 2 CO2s. And let's now take care of our hydrogen. That should also fix our oxygens. There are 1 times 2 times 2, 4 hydrogens, plus these 2 hydrogens here. That gives us 6 hydrogens. I have 1 hydrogen here, 1 hydrogen here, and I need 4 more, so 2 H2Os as well. Now let's check out oxygen to see that our work is a good one. 6 plus 1 times 4 times 2, which is 8, is 14 oxygen, and thus I have 4, which makes 8, 4 here, which makes 12, and 2 more, which makes 14. So that's also balanced. Let's move on to yet another example. S8 plus F2 giving you SF4. Okay, good variety, not maximum, not the variety, not the maximum, and this has maximum but not the variety. But if I start with this putting a 1, that would actually mean that I have, it should be 1 over 8 to make that, and I have to multiply everything by 8. That's the problem. So if I do that, oh, and if you multiply this by 8, it would be just 1. So that's now 8 sulfur, and 8 times 4, it's 32. It should be 16 times 2 to make it 32. Okay, that's now balanced. Let's do it another example. NCl3 plus H2O giving you NH3 and HOCl. Okay, hypochlorite hypochlorite acid. Okay, let's see how much time we have. We have still a little bit time, so I can make it to the end. So with this one, I could start with either this one or this one. This has oxygen, this is nitrogen, and it both has chlorine. This has more chlorine, and this also has nitrogen, so I'll go with this one. One nitrogen CO3 means one nitrogen, one CO3 means 3 Cl1, and then 3 chlorines here, 3 chlorines here. With doing this, I have just done my hydrogen or my oxygen, so I could actually start with hydrogen or oxygen and check the other one. Let's just do hydrogen first. 3 hydrogens here, 3 hydrogens here, that's 6 H, and 3 H2 would make 6. 3 oxygens, also 3 oxygens, so oxygen is also balanced. Checked on both sides, okay? That's this. Let's move on to yet another example. So the idea of N2O5 giving you NO2 and O2 is a reaction that is a decomposition. We will also, hopefully I will talk about the nature of the chemical reaction sometime, but let's first do the balancing of this one. So I do one here, it has the variety and maximum number. If I do one, that's 2 here, and that's 5 oxygens. I have already 4, so I need one more, so I do half to get 4 plus 1 from here to make 5 oxygens overall, okay? And that I could now multiply everything by 2 to get their balanced form without any fractions, okay? That's 2 for 1. Let's do CO plus I2O5 giving you CO2 and I2, okay? So let's just start with this one that has iodine and big coefficients. So I do one here, I do one here. If you have 5 oxygens, okay, for this one, what you have to do is to figure out the number of X here and try to find out what this is, okay? Because you can't judge. That's a little bit complicated than the other examples that I have just done, but it's still doable, and it's doable by assuming I don't know what this is, but let's just assume it's X. Now with taking that as X, I have to solve for an equation, okay? Because that is the number of oxygens. If I do oxygen first, I have 2x oxygens, I have 5 oxygen here, and I have, if I put y here, it means y plus 5 should be 2x. That's for oxygen. For the carbon, I have to say x is equal, because it's x times 1, y, okay? So x and y are equivalent, so I could just put y as an x here on my first equation and solve for that. Now x, if I move it to the other side, it becomes 2x minus x, it becomes x equals 5, and I could do 5 here as well as 5 here. Then you could check to see that your carbon, you have 5 carbon and 5 carbon, you have 5 oxygens and 5 oxygens, that's 10, and then you have 5 times 2, it's also 10, the oxygen is also balanced. We will rarely run into examples like this, but if you ever did, and the problem for that was, like, we can't figure out these 5s from this, because when you put 1 here, you could judge the number of iodine and you could do this, but there is no, you can't judge the number of oxygens on this side completely because you don't know this, and also you can't judge the number of any other elements because you don't know anything other than the coefficients for your oxygen. Also, if you do it for your I believe, let's just give it a try, I think I have enough time. I believe that if you start with carbon, maybe then you could do something, okay? So 1 CO2 and 1 CO here, has one carbon, and then 1O2, that's the number of oxygens here, so you have two oxygens, and you have one oxygen already, and you want one more oxygen, so you do 1 over 5. Yes, so if you start with this, you could actually handle that problem. So that's also on this video. So let's just finish this. If I do 1 over 5 I2 here, and I multiply everything by 5, so it's 5 1 5 1. Okay, so if you start with this, you could actually handle the problem, or you have to do the equation things that I did at the very end. I want to wrap it up here for this video on chemical balancing chemical or simple chemical reactions, and that's it.